Welcome back. All right, in this last video for transformation and translations, we are going to just real quick do a little review that we're talking about translations, which are isometries. Remember, your pre-image happens before you've done your transformation, and then your image is what the resulting figure is. And we are going to be doing isometries today because we're just sliding figures with translations, so our shape and size are preserved. We talked about coordinate notation. When you add to x, it moves you right. When you subtract from x, it moves you left. If you add to y, it moves you up. And if you subtract from y, it moves you down. So when you want to write coordinate notation that says we're going to move this figure 8 units to the right and 3 units down, we're adding 8 to the x, and we're subtracting 3 from the y. Okay? Let's try that with this example down here. Write the coordinate notation for the translation to the right. So it's real tempting to just go, okay, so to get from here, from this figure to this figure, I'm going here, so I just need to look at this little distance. But remember, you have to match up corresponding pieces. You have to match up corresponding pieces. So that means I need to go from R to R prime, or N to N prime, P to P prime, or Q to Q prime. So we need to make sure we're looking at what is this change right here. Okay? Because it has to go correspondingly. Okay? So I can see that my original image values, this is my pre-image because there's no primes, right? And this one is my image because I have my primes. So that's how I knew I was going to this one here on the right. Okay? So x, y, my pre-image point, is going to, we're going to change our x and we're going to change our y. But by how much? I can see I'm moving to the right, so I know I'm adding to x. I can see I'm moving down, so I know I'm subtracting from y. But how much, right? So how much am I moving to the right? 1, 2, 3, 4, 5, 6 to the right. How much am I moving down? 1, 2 down. So here is my coordinate notation. Okay? If we want to check that coordinate notation, then what we need to do is just pick two corresponding parts and make sure that the x is increased by 6 and the y has decreased by 2. So since I went from R to R prime, those are the ones I'm going to use to check. And really, you could check all 4 if you wanted to. R is at 1, 2, 3, 4, 5, negative 6, and negative 1. And R prime is at 0, negative 1, 2, 3. So let's see. X plus 6. If I do negative 6 plus 6, that does get me to 0. And then y minus 2. Negative 1 minus 2 does get me to negative 3. So I can feel confident that I did my coordinate notation correctly. Okay? Sometimes you're not going to be given a graph. So if you have graph paper, that's great. But let's talk about what to do if you don't have graph paper. How can you figure out where your new points will be, right? So you just have to work and do it mathematically, okay? So as we go through, my first one says apply the properties of coordinate notation. What is the image of W, 7, 12, under the translation xy becomes x plus 7, y minus 3, okay? So this one does not have a prime on it, so I know this is my pre-image, and I'm trying to figure out what is my image. So remember, this is my pre-image, and this is my image. So to get from here to here, I need to look at what it's asking me to do, right? It's asking me to add 7 to the x value, and it's asking me to subtract 3 from the y value, okay? So if I do that, I'm going to add 7 to the x value, and I'm going to subtract 3 from my y value. And that's going to give me my image, which is going to be labeled W prime, because it's my image. Okay, so when I add 7, 7 plus 7 is 14. And then when I subtract 3 from the 12, I'm going to end up at 9. So W prime, I'm trying to darken this in, it's kind of a bright marker. W prime is the point 14, 9. And that's going to move me to the right, and it's going to move me down, because I'm adding to x and subtracting from y. Okay? All right, let's look at the next one. What is the image of j, 5, negative 2 under the translation xy translates to x minus 2, y plus 4? So in this one, again, when I look at this, I can tell that because there's no prime, this is my pre-image. And I'm trying to find the image. This is my pre-image, and I'm trying to find the image. Okay, so to my pre-image, I am supposed to be, let's see what it's asking me to do. It says to subtract 2 from my pre-image, and then add 4. So I know if this was on a graph, I would be moving left 2 and up 4. But to find my image coordinate, I don't need the graph, because I can just do the math, right? I can say, okay, 5 minus 2 is 3. And negative 2 plus 4 is a positive 2. So if j is the point 5, negative 2, then j prime is 3, 2. Now the next ones are kind of interesting, because on the next ones, it's not asking me to find the image. This time it says, what is the pre-image? So I'm trying to find this one. I'm trying to figure out what was the original xy. If they gave me the image. So they've already given me, they've already added the 7, and they've already subtracted the 3. So I need to work backwards to get to my answer. So when I'm working backwards, if I want to work backwards to where I originally was, we have to do the opposite of what we did. So instead of adding 7, if I want to work backwards, I'm going to be subtracting 7. Instead of subtracting 3, if I want to work backwards, I'm going to be adding 3. Okay? So this time, I'm working backwards to find z, because they already gave me the prime value. I want the pre-image value. When I work backwards, I get negative 3 minus 7 is negative 10. And then 8 plus 3 is 11. So that if I were to do negative 10 plus 7, that's going to get me to my negative 3. And if I do 11 minus 3, that gets me to my 8. So again, if they give me the image and they're asking me what is the pre-image, I have to do the backwards, the opposite, or the inverse functions of what's in my coordinate notation. Okay, let's do one more like that. Okay, so when I'm looking at the next one, it says what is the pre-image of m, 7 negative 4, m prime, that's important to note, 7 negative 4 under the translation xy translates to x minus 2, y plus 4. So I know to get here, I moved left 2 and up 4. But I want to work backwards to get to m, right? Because they gave me m prime. So I want to get to m. Let me use a darker green, because that green's difficult to see. Okay, all right, so what I'm going to need to do is I'm going to need to work backwards. Instead of subtracting 2, I'm going to need to add 2. And instead of adding 4, I'm going to need to subtract 4. So 7 plus 2 is 9. And negative 4 minus 4, be careful, it's real tempting to say that's 0, but they're both negative, right? So if I'm at negative 4 and I go negative 4 more, I'm actually at negative 8. Okay, so there is my image, or my pre-image, when my image is 7, -4. And if I want to check it, if I do 9 minus 2, that gets me to 7. And if I do -8 plus 4, that puts me at my -4. Okay? So sometimes they'll just give you the coordinates. They won't give you the graph, and you'll need to be able to apply the coordinate notation, sometimes as it is if you're looking for the new image, and sometimes you have to do the inverse to work backwards and do the opposite of each of these functions if you're looking for the pre-image. Okay, so you might want to make yourself that little note if you're copying these notes yourself. When you're looking for image, use coordinate notation as written. Finding image. Down here, when we're finding the pre-image, we need to work backwards. Use opposite operations, right? Instead of subtracting, we add. Instead of adding, we subtract. Opposite operations. Okay? All right, so hopefully that helps you with translations. If you have any questions, please make sure you ask during sync time, either during the actual sync time or afterwards during tutoring. Thank you so much for watching.